Assalamualaikum and thank you to Alisa. Now, I will continue my topic which is quantization. This process of converting the real numbers to the predefined discrete number is called quantization. Quantization is the process of mapping input values from a big set to output value in a smaller, sometimes with a finite number of elements in mathematics and digital signal processing. Quantization techniques include things like rounding and truncation. Quantization is also at the heart of almost every lossy compression method. Quantization error is the difference between an input value and its quantized value. A quantizer is a device or computational function that conducts quantization. A quantizer is something like an analog to digital converter. Image at the left side is the example of quantization. Next, I will explain about type of quantization. First, scalar quantization. A mapping of an input value x into finite number of output value y. Second, uniform quantizers. The type of quantization levels that are uniformly spaced. And the last one is non-uniform quantizers. The type of level that are unequal is the non-uniform quantizers. The last topic is scalar quantization. A scalar value is chosen from a finite list of possible values to represent a sample in scalar quantization. A vector is chosen from a finite list of possible vectors to represent an input vector of samples in vector quantization. Next, scalar quantizers are divided into two categories. The mid-range quantizers, for example, does not have a zero output level. The other is known as the mid-rate quantizer and one of the output value is zero. This is an example of mid-rise and mid-rate. Then I will pass next presentation to Nurul. That was from me. Thank you.
Thank you to Izzati for the explanation just now. Next, I will continue to introduce about the uniform quantization. Okay, this is what we call uniform quantizer. A uniform quantizer is the output level that are spaced and equidistant apart and the threshold between the adjacent level. So, uniform quantizer are one in which the same increment size that calls stack size utilizer for both input x and output q of the step value of x. This is the example for two adjacent range value on the x-axis which are ki and ki minus 1 or then it will be q ki minus q ki minus 1 equal to ki minus ki underscore 1 for all the I equal to any number of given. Okay, we will find the midpoint with the two adjacent with the step value ki minus ki underscore 1 divided by 2 and q open bracket q open bracket ki close bracket minus q open bracket ki minus 1 close bracket and divide by 2, then we will get the midpoint value. This is the example which is two range of the adjacent and how to find the midpoint value. Okay, this is the quantization error. So the difference between the quantizer and unquantized value is called a quantization error. This indicates the distortion caused by the quantizer. The error can be expressed as the EQ equal to x power of 2 minus x. The step size should be value Ri, where I could be any number 1, 2, 3 or any other numbers. Okay, so this is the figure that shows a quantization error EQ between the original sample value and the value produced by the quantizer. Okay, this is the most common distortion measure error. We have a square error distortion and average distortion. The most common distortion method is the square error distortion for each error. The mean square error distortion is used to measure the average distortion for the quantizer. Okay, finish about the uniform quantizer, so we move to the non-uniform quantizer. Okay, the non-uniform quantizer is the type of the level that unequal is called non-uniform quantizer. So, non-uniform quantizer use a various variable step size. Different step size are applied to different amplitude of an input via a non-uniform quantizer. Okay, this is the example of non-uniform quantizer. Okay, for example, two functional types are used in the non-uniform quantizer, that is power law compounding and logarithmic compounding. So the word compounding is derived from the word compressing and expanding to the reflect of two activity involved. So the model has small change on the low input value and a large change on the high input value, so that can lead to the similar size step on the output of the quantizer. Okay, this technique will reduce the noise and the crosstalk of the level at the sound receiver. Okay, as we can see in this video, in a power law compounding, a power function is used as C power, open bracket, equal to x, close bracket, equal to x power of p, and in a logarithmic compounding, we use a log x as the logarithmic function. Okay, we can see a line that we call a power law compounding function. So we describe p equal to 0.2, 0.3, 0.4, 0.5, and 0.7 at last. Okay, I think this is my last point from me. That's all from our group presentation. Thank you for listening.